الرحمن الرحيم.
The given vectors are solutions of a system x prime equals a times x. Determine whether the vectors form a fundamental set on the interval from negative infinity to positive infinity. So we have this first vector x sub 1, which consists of the column containing 1 and 1, multiplied by e to the minus 2t, and the vector x sub 2, which consists of the column containing 1 and negative 1, multiplied by e to the minus 6t. So we have these solutions. The first solution, x sub 1, if we multiply this out, will consist of e to the minus 2t and e to the minus 2t. And then x sub 2, that will consist of e to the minus 6t and minus e to the minus 6t. And so we wish to verify or to determine if these form a fundamental set on this set of real numbers, where t is between negative infinity and positive infinity. Well, if these form a fundamental set of solutions, what will happen is that means that x sub 1 and x sub 2 will have to be linearly independent. And we know that x sub 1 and x sub 2 will be linearly independent if the Wronskian of x sub 1 and x sub 2 is not equal to 0. So we'll find the Wronskian. So the Wronskian of x sub 1 and x sub 2, that will be the determinant of, well, our first column will contain x sub 1. We'll have e to the minus 2t and e to the minus 2t in our first column. And our second column will contain the vector x sub 2. We'll have e to the minus 6t and negative e to the minus 6t. So we'll find this determinant. So we'll multiply the e to the minus 2t and the minus e to the minus 6t, and then we'll subtract the product of the other two terms, e to the minus 2t and e to the minus 6t. And so what will happen is this will give us minus e to the minus 8t minus e to the minus 8t, and that will give us minus 2e to the negative 8t. And e to the negative 8t, this exponential function, can never be 0. So this Wronskian, negative 2 times e to the negative 8t, this will not be equal to 0 on this open interval from negative infinity to positive infinity, which tells us that our vectors or solutions are linearly independent, which means that x sub 1 and x sub 2 do form a fundamental set on this open interval from negative infinity to positive infinity.